Okay, let's make some TF-records. TF-records are a file format that you can use for machine learning training data. They're really nice because they're serialized, so that way you can read the data back out really quickly, and it will save you time during the training process, so that way the reading and pre-processing that data is not the bottleneck. They're nice whenever you have more data that you can fit in memory, especially when that data is complicated, like an example being mixtures of integers and floats, or even strings. TF-records are the way to go for that type of data. So we're going to do a little quick example here, just writing some integers to a TF-record file, following up by another notebook that will write some floats. So first, let's import NumPy and TensorFlow, NumPy to create our example data, and TensorFlow to write the TF-record. We're going to be writing 10 examples with 10 features each. So it's going to be a 10 by 10 array that we're going to be creating. And we're going to do that right here. So examples are np random randint, going from 0 to 100 with the size of n examples by n features. So there's our array that we're going to be writing. And then printing it back out, we're going to make the label be the row index of the array. So for example, label 2 is for our third row. It's going to be the numbers 16, 79, and 47 going in, plus the rest of it. Those are just our first three. So we can see whenever it comes back out. So let's go ahead and write that data to a TF record. Pretty quick and easy. We're going to create a file handle with TF.io TF record writer, providing a file name, and it's going to spit back out TF record as our file handle. Then we're going to loop through that array of data. Again, taking the label as the index, and our feature is going to be the row of that data. And then here we create a dictionary for our feature. The keys, you can make them anything that you want. I've set them here to be label and feature, just so that way it's really apparent. But these could just as easily be class or spectrogram, or flower type and petal lengths, anything. Going into each of these are going to be a TF train feature. Here we're using the argument for int64 list because we're just passing in integers. So it's expecting a TF train int64 list, and the value of that will be a list. So that's why we wrapped our label, which is just a single number here, but we wrapped it in a list. It could be additional numbers, but we just have one going in for the row. And then our feature here, again, the value is the feature, which is just that row of data. We're going to take that feature and make an example with TF train example, sending in the features of TF train features, feature equals features. Again, this is probably the only complicated part of writing or using TF records, is the syntax is a little redundant, but it's really quick and easy to do. So for that example, we tfrecord.write example to serialized string. And again, we go through each row of that array and write the example for each. Okay, let's look at how to take that data back out. This is what we'd be doing during training time. We're going to make a data set right here with dataset equals tf.data.tfrecord dataset, and providing that same file name that we just wrote to. Then we're going to take that data and that data set, and we're going to map it through our map function. Map function looks pretty similar to what we just used. We're going to create a dictionary, again with the same keys that we used before. And again, these keys could be anything that we set. They just have to match what we have going in. And the value of each is going to be a TF.io fixed length feature. So we're going to be saying how long this feature is and what type it is. So for our label, we're saying it's a size 1 and it's an int64 coming out. For our feature, it's n features, which is 10, and it's also an int64 coming out. Then we're going to create the example from TF.io parse single example, which is going to give the argument to the map function, and then our feature dictionary. And that will give us out the example, which will be a dictionary. We're going to be passing back a tuple of the feature and the label values. So that's where we get our data set. And then we're going to go ahead and just do a check here and make sure that the data coming back out is the same thing we put in, what we're expecting. So we're going to say for feature, label, and dataset.take10, taking all 10 pieces of our data. We're going to print it back out. And let's look at number 2 again. Again, label 2, we have 16, 79, 47, which is the same thing as here, 16, 79, 47. So those are all integers, quick, easy example. Next, let's go ahead and look at floats. But before we do, we pause this video and go to the Google Play Store and download Birder.ai. It's a bird sound identifier that my wife and I wrote that can classify birds based on their calls. So if you've ever heard a bird and wondered which type of bird it is, Birder.ai can tell you that. It uses your phone's microphone to listen to about 10 seconds of audio, and then it classifies it based on 1,000 different birds that it knows. So Birder.ai, it's in the Google Play Store, and you should go download it. All right, same exact example, except this time we're going to be using floats. So we're going to import NumPy and TensorFlow. Again, 10 examples, 10 features. The difference here is that for our examples, we're going to be using NP random rand to create float numbers. And again, we're using 10 by 10. So 10 rows with a width of 10 each. And that's our array coming out. And we're going to be looking again at index number 2, which is going to have 0.86, 0.05, and 0.51 as the initial numbers. All right, now let's loop through each one, again using the index as the label. So for label 2, that same number, 0.86, 0.05, 0.51. Creating our TF record from it. This is where things change just a little bit, and really they only change here at the feature part of our dictionary. So again, we're taking TFIO, TFRecord writer to create a file handle that we're going to write to, and we're going to loop through that example array. Creating our label and feature again as the index and then that row of data. And then in our feature dictionary, we have our label again in 64 list, but our feature, this is where we change. The argument that we're sending into is a float list, and we're using the TF-train float list function to format that, passing in the value as that feature. To create our example, TF-train example, and then we're setting our features to a TF-train features, passing in that feature as the argument. And then we're going to take TFRecord.write and write that example serialized to a string. Again, just going through each one. Let's write that. Okay, and then we're going to read that data back out just to see how we do it. Pretty similar again. We're starting with a data set from TF-data, TF-record data set, passing that file name. Then we're going to map it through our map function. We have our feature dictionary. The label looks the exact same as a fixed length feature of N64 type. The feature here though, again, also a fixed length feature of N features length, but TF-float32 is the type coming back out. So it's going to be parsing that back out with the TFIO parse single example and give us back a dictionary where we have a feature and label key, or whatever keys that we had going into this. And then to read that back out, for feature, label, and dataset.take10, let's print it back out. We'll look at label 2 right here. Our feature is .86, 0.05, 0.51. So exact same numbers that we had going in are coming back out. And we could use that data set to go ahead and train a model with. So that's how you use TF records for integers and floats. Like I said, you can also use byte strings as well. It's a great file format, and I highly recommend it if you have more training data that can fit in memory, or it's complicated training data, a mixture of different data types, like integers and floats. Before you go, remember, go to the Google Play Store and download Birder.ai. It's a great app. You'll like to use it. Leave a review. Let me know how it is. Okay. Thanks for watching.